So what if you are told to do BCD addition? That is, you are given two BCD numbers and you want to add them without going through the binary conversion. And you say that is possible. However, this often produces some invalid BCD codes, and for this reason, the following rules have been formulated to allow us to do BCD addition. Number one, if the sum of two BCD numbers is less than or equals to 9, then the sum is a valid BCD code. On the other hand, if a carry bit is generated and the sum is an invalid BCD code, the correct sum is obtained by adding binary 6 to the invalid sum. We will look at that to understand the example. In a few words, this has the effect of skipping the 6 invalid codes that exist within the 4-bit sequences from 10 all the way to 15. If there is no carry and the sum is an invalid BCD code, then the correct sum is obtained by the addition of binary 6 to the invalid sum. I think we will just look at the example so that we can see how those rules apply. An example, perform an addition of the following BCD code. 1, we want to do this one. So this is, we want to add, so I'll just arrange them going downwards, 0, 0, 0, 1, and we have 0, carry 1, 1, 1, 0. So this is equivalent to what? This is equivalent to 6. And therefore, since we know this is 5 in decimal, this is 1, then this is a valid operation. So we have been able to perform BCD addition by just directly adding the two BCD numbers. Now we want to do another example. Given these two numbers, perform the BCD addition. This is if we just add them directly. I'll put this one here and do the addition 1 0 0 0 1. So the rules say that in the event we have a carry which is producing an incorrect sum, what we do is simply to add decimal number 6 represented in binary by 0 1 1 0. So when you add this to this sum, you end up with 1 1 1 0 1. And of course, we add zeros to the left to form the BCD code of 4 bits each. And therefore, when you check this one in its decimal equivalent, we see this is 7 and this is 1. And if we quickly check what this value was, we will see that this was an 8 and this was a 9, which when you add, you get 17. So 17 in BCD form is definitely represented by this number. So we have obtained the correct answer after adding decimal 6 to the incorrect sum that we obtain here, because this involved a carry. However, we will meet another example that says, I think we should go to those rules now and see what they mean. We had said here that some rules apply. If the sum of two BCD numbers is less than 9 or equal to 9, the sum is a valid BCD code, and that we have done using the first example. The second example that we have done that involved 9 plus 8 has given us 17. There was a carry involved, and that carry, because we have found a carry, we have said that we have added binary 6 to the invalid sum, and we have been able to obtain 17 represented by in its BCD format. The number 3 is this rule: if there is no carry and the sum is invalid, then the correct sum is obtained by just adding the binary 6. We will see that in the next example. So this example shows that if you are told to do this BCD addition, this is the first BCD code, this is the second BCD code, this is the other one, this is the other one. So how can we add these two? We just arrange them going downwards. So we say 1 0 1 1 1. When we do this addition, we have what? 0 plus 1 1, 0 carry 1, 1 carry 1, 1 0 1 1. So this answer, if you are to check, this is equivalent to a 5, this is equivalent to a 6, this is equivalent to an 8, and this is a 7. So what we are doing here is we are doing 56 plus 87. What we know definitely here is that this will give us 13 carry 1 14. So this cannot be represented by two sabers like we have here, or 4 bits each. Therefore, we know this sum is incorrect. So what we do is to add. There's no carry there, but we can see that this number cannot be represented by that. So we do is simply add a binary 6 represented by 0110. The rule says that we should add binary 6 to each group. So here is group 1, we add a 6. Here is another group 1, we add another 6. So what we end up with is, this gives us that, carry 1, this gives us this, carry 1 again, this gives us, yeah, there's a 0 that is missing here. Yes. So we have 3 groups now, and if we now check them out in their decimal representation, this is equivalent to a 3, this is equivalent to a 4, and this is equivalent to a 1. So the final answer is 143, just like we have in this manual addition of decimal numbers.